Hey, what's up? Welcome to this new video. This one is paper 1 of October-November 2007. Now with that being said, let's move on to question number 1. So let's see what do we have over here. So we have to find the set of values of k for which the line does not intersect the curve this, which means the line and the curve does not have a solution. So when we know this, we have to realize this will lead to a question of b squared minus 4ac have to be less than 0. So first thing first, we have two equations. This is the first equation and this is my second equation. Here we have y as subject already. We just replace in this y. You will have 4x plus k have to be x squared. So let's rearrange. You will have x squared minus 4x minus k have to be 0. Now value of a is 1, b is minus 4, and c is minus k. So b squared is minus 4 squared minus 4 times a times c, and have to be less than 0 because they do not meet, which means they don't have any solution. Now let's simplify. If that will become 16 minus become plus 4k, right? So 4k minus 16, so k have to be less than minus 4 as your answer. This is the set of values of k for which they do not meet. Now let's move on to the next question. So here we have to find the area of the region enclosed by the curve this. So what is this? It is 2x power half, right? Because we know square root is simply power of half. Now, and the line x equal to 1 and x equal to the value of 4. Now, just to have an idea, we can make a sketch. That will be the axis, y-axis, and the x-axis. Now, we can kind of realize as the value of x increases in this direction, what happens? We can check. So x, so root of 1, this, root of 2, this, root of 3, this. As you can see, it increases, right? As the value of x increases, the value of root x also increases, which means the value of 2 root x also increases. It is just an idea for us to make a sketch, so we can simply assume the graph will look something like this. It is only a sketch. Now we have 2 points here. We have x right here, x equal to 1, and we have x equal to the value of 4. Now we're trying to find the area enclosed, so just this area. So what is this? It is area under graph between those limits. So area integration, that will be limits of 4 and 1, y is equal to 2x power half with respect to the x. So step by step, I can take out the value of 2 first, right? Then first increase the power by 1, that will be 3 over 2, divide by the power, and then we have limits of 4, 1. So simplify, that will be what? 2 is outside. This is simply, if you have to simplify, we have to send this up, that will become 2 over 3. But let's take this outside. You will have x, this inside. You have 4 first, and then minus 1, 3 over 2. Okay, so just so you guys are not confused, what happened here is I have 2 outside. On the inside, I want to simplify this. So this will become 2 over 3 x 3 power 2. Now realize this one is only a multiple. I can take this outside. That will be simply 4 over 3. And on the inside, I will have x 3 over 2 and limits 4, 1. So replace 4, replace 1. You will have this for now. Now 4 power 3 over 2, that should be 8, and that should be minus 1. So you will have 4 over 3 multiplied by 7, that should be 28 over 3. Of course, write units square for the area enclosed in that region. Let's move on to the next question. So find the first 3 terms of the expansion this in ascending powers of u. So pretty easy. We have 2 plus u power 5. So the first term is 5 choose 0. Here we have 2, and then we have u. We have 0 here, this will be 0 as well. 5 minus 0 is 5. Next term, 5, choose, after 0 we have 1. Then that will be 2 here, and then here we have u. If it is 1, that will be 1 here. 5 minus 1 is 4. And third term will be 5, choose 2, 2 and u. That should be 2 here and 3 here. So 5 choose 0 is just 1. 2 power 5 is 32. This will be 1 plus 5 choose 1 is 5. That will be 16. And that should be u. 5 choose 2 is 10. That should be 8 and u square. So simplify. That will give you 32 plus what? 5 times 16, that will be 80. So 80u plus 80u square. This is the first 3 term of the expansion. Now we have to use this substitution in your answer to part 1 to find the coefficient of x squared in this expansion. Okay, so let's observe what's happening. So the expansion here we have is 2 plus x squared. Now we are saying that this is actually u, so this is the same thing as power 5 obviously. 2 plus u power 5. So same kind of expansion, right? So we just have to use u equal to x plus x squared. So let's see what happens here. 32 is a constant, we don't care, that should be 80 times u, that should be x plus x squared plus 80 u squared is u squared. That should be what? That should be x plus x squared squared. Simplify, that will give you x squared plus 2x cubed and plus x power 4. Okay, now we just have to simplify. But here we only care about what? About the coefficient of x squared. So we just have to find the term in x squared. So here we don't need this one, we just need 80 times this, that will be 80 x squared. Here we have plus 80, we need just this one, x squared. So this plus this, that should be 160 x squared, and the coefficient is just the value in front, that should be just 160. Okay, and that will be your answer for question part 2. Let's move on to the next question. The first term of an arithmetic progression is a, and the common difference is d. Okay, now at least we know the type of progression that we have to work with. That's the first good thing. Now once we know that, let's write down the formulas we know for that kind of progression. So the n term is given to you by a plus d n minus 1. Sum of the first n term is given to you by half times n 2a plus n minus 1 times d. Okay, so these are the two equations usually we should know for the AP progressions. Now part 1, we have to write expressions in the form of a and d for the 5th term and the 15th term of this progression. So one by one, pretty easy. Replace back in your formula here. Let's see what do we have. So 5th term is what? When the value of n is 5, you will have a plus d. 5 minus 1 is 4. So you have a plus 4d equal to the 5th term. Right. Now what else do we need to know? The 15th term, so 15th term, same steps, a plus d. 15 minus 1 is simply 14. Have to be a plus 14d. Okay, so 5th term and 15th term given to you by those two expressions. Okay, pretty easy till now. Now the first term, the 5th term and the 15th term, so the first term, the 5th term, and the 15th term, which is this one, are the first 3 terms of a geometric progression. Okay, so now these 3 are the first 3 terms of a GP. Great to know. Now GP, let me first write down all the formulas we know for GP. So we know the n term is given to you by a r n minus 1. Then we know the sum to infinity given to you by a over 1 minus r. And the first term is obviously just a. That is for GP. Again, this is given to you as well in your list, so you don't need to worry about those. But it's always best to kind of write this down for now, and then you can use that directly to find your following values or the answers. So we have to use this information to show that 3a is equal to 8d. So how can we use that information? This is my first term, second term, and third term. So we have to show 3a equal to 8d, and then we have to find the common ratio, what is the value of r in this progression. So let's think of this one by one, and let's try to find the following values. Okay, so now we understand what? We understand that. So for example, from this term to get to the second term, if it is a GP, we have to multiply by r. Same thing here, multiply by r, right? So let me write this down. We know that from the first term, if you multiply by r, you will get the second term. And from the second term, if you multiply by r, you will get the third term. So here we can use that information or equation to solve or to show that we have 3a equal to 8d. First thing first, let's make r become subject. That will be this divided by a, and r will be this divided by a plus 40. Now obviously we can solve a simultaneous equation because r is obviously equal to r. So on the left hand side you will have a plus 40 over a is equal to a plus 14d over the value of a plus 40. Now we can simply cross multiply. You will have what? On one side you will have a plus 40 square, and that will give you a square plus 1480. So now we just have to simplify. That will be a square plus 8ad plus 16d square is equal to a square plus 1480. Now these two will obviously cancel out. So finally, we have to send this over here. You will have 16 a square, so d square is equal to 680. Obviously, cancel d, that will be 16d will be 6a. Divided by 2, you will have ad will be 3a, which is the same thing as saying 3a is equal to 8d. This is shown as required. So now we have to use this value to find the value of r. So let's replace back in this equation. Now here we have 8d, but here we have 40. How can you make 8 become 4? Divide by 2. You will have 40 here, and that will be 1.5a, right? So replace this by this in this equation. So r is equal to a. 40 is 1.5a divided by the value of a. That will be 2.5a divided by a, and that should be 2.5. Okay, so your common ratio is equal to r, and which is simply 2.5 for your answer. Okay, and this is the question number 3 for this GP question. Let's move on to the next question. So here we have to show that the left hand side equal to the right hand side can be written in this form. So we have to simplify this into this. So step by step, here we have 3 sin x. Now what is tan x? It is sin x over cos x is equal to the value of 8. Now we can obviously simplify. Sine times sine will be 3 sine square x, and we can send this over here. Obviously that will become 8 cos x. Now we know that sine square x is actually equal to 1 minus cos square x. If you guys don't know this, then it will be a problem. You have to know this ID to solve this question. That will be 3 minus 3 cos square x is equal to 8 cos x. Simplify. 3 cos square x, send this over here obviously, and that will be plus 8 cos x minus 3 is equal to 0, and this is shown as required. Right, now hence means we have to use part 1 of your answer to solve this equation for the value of x between 0 and 360. So pretty easy. We have 3 cos square x plus 8 cos x minus 3 equal to 0. Now if you guys find this hard to work with, you can always let u equal to cos x. You will have 3 u squared plus 8u minus 3 is 0. Now we can factorize. That will be 3u times u. 3 is 3 times 1. To get plus 8, we have to have plus 9 minus 1. U have to be 1 over 3 and U have to be minus 3. But now again, we are trying to find the value of x, not U. Replace it back. U is cos x is 1 over 3. Cos x is minus 3. This will not be possible. It is invalid because the value of cos x can only be between minus 1 and 1. You can check as well. Cos inverse of 3, error. Cos inverse of minus 3 should also be error. For this one, now since cos is a positive value, we know it has to be in the first quadrant and in the fourth quadrant. So x can be simply cos inverse of 1 over 3. So here we have to use degrees. That should be 70.5. And then also for the fourth quadrant should be 360 minus answer should be 289.5. So here we have the two values of x for which it satisfies this main equation. Let's move on to the next question. The 3 points A, B, and C are shown in the diagram. Okay, good to know. Now, the point E is such that the line DA is perpendicular to AB. So the line DA is at right angle to the line of AB. And DC is in the same direction as AB. Okay, as we can see here, they are in the same direction. Now what else can we know? We have to use this information to find the value of the point D. Now we can clearly see that the point D is the point of intersection between the line AD and the line CD or DC, same thing, right? It is the point of intersection. Now to find this, we obviously have to solve two equations simultaneously because it is a point of intersection. Now let's first find the equation of AD. So to find the equation of AD, obviously we must first find the gradient of AD. Because it is at 90 degrees to this line, we understand that we can first find the gradient of AB and then derive the gradient of AD. So let's find this. What is the gradient of AB? That will be y2 minus y1 over x2 minus x1. That will be minus 6 over 3. That should be minus 2. So finally, gradient of AD should be the value of half. Now here we have a passing point here, which is A, 3, 8. That is x and y minus 8 over the value of x minus 3. That should be 1 over 2. Cross multiply, you have 2y minus 16 have to be x minus 3. So 2y have to be x minus 3 plus 16 should be plus 13. Right? So this is the equation for your line of AD. So now we have to find the equation of the line CD. So how can you find this? Obviously, we have to first find the gradient. So since the line AB and the line DC are in the same direction, we understand that the equation of the gradient of the line DC have to be the same as the one with AB, which is minus 2. The passing point here we have C as the passing point, which is 10, 2. This is the x value and the y value, so y minus 2 over x minus 10. That should be minus 2 over 1. Again, this is just a method that I use to find the equation of a straight line. If you have something else, you can use your own method. Cross multiply, you have y minus 2 is equal to minus 2x plus 20. Now continue. Y have to be minus 2x plus 22. This is my equation for the line DC. Now pretty simple. We have this, we have this. We just have to solve them simultaneously to find the point of D. So here we have y. We can replace directly in here. You have 2 times y, which is this value, x plus 13. That'll be minus 4x plus 44 is equal to x plus 13. Let me send this over here. You will have 5x. And what is this going to be? 44 minus 13, that should be 31. X will be 31 divided by 5, that will be 6.2. And y will be the value of minus 2, answer, plus 22. That will be 9.6. So let me double check if that is okay or not. Let me put this back in this equation. 2 times y 9.6 is this value. Now if you have 6.2 plus 13, that is also the same value. So it seems to be fine. So D will be the point, 6.2 and 9.6. Okay, and that will be your question in relation to coordinate geometry. Again, if there's anything, a step that I missed, let me know in the comments below, and I will get back to you as soon as possible. So moving on to the next question. In this diagram, we have AB is an arc of a circle, this one right here. Now the center is O and the radius is R. So this is R. Well, this will be also the radius, right? Because they are the radius, arc. This will be a sector of a circle. Now the angle OAB is theta radius. So the angle right here is theta. The point X lies on OB, and we have AX is perpendicular to OB. As you can see here, it is a vertical line at 90 degrees to OB. Now part 1 of the question, we have to show that the area of the shaded region AXB is given by this formula. Now, how can you find the area of that region? Right. Now we have to think step by step. To find the area of this region, we can first find the area of the whole thing, of the sector, right? So number 1, let's find the area of the sector OAB. Now to find the area of sector, we will be using a formula. You guys have to know this. It is equal to half R square theta. Now obviously half is half, R square is the radius, so radius is R as well. Theta is the angle here, and angle is theta as well. So this is the number 1, which is the area of everything. That is part 1. Now for part 2, to get this part of the area, we have obviously to remove this part. Now what is this part? As you can observe, it is simply triangle, right? Triangle OAX. Now as we can see, this one is a right angle triangle. So how can you find the formula for a right angle triangle? I mean, not formula, but the area. My apologies. The area for the right angle triangle. Let's observe. So we know we have a few ways. We can use half times base and times the height. So here we only have this value over here. We have this value over here. So we have to find this value, because to find the area, we have two ways of finding the area of a triangle. We could use this one for a right angle triangle, or we could use half sine of the angle in between and times the two sides. So times OX and times OA. Up to you. You can choose which one you want to use to find the area. So I think I would use the easier one, which is this one, to find the area. So right now, let me draw this outside. I have a right angle triangle. I want to find the value for the height and the value. This is OX. This is R right here. This is theta. Okay, so to find for the height, for example, what would that be? I will use SOHCAHTOA to find that value. I have the hypotenuse, HH. I'm looking for the opposite side, so O and O. So here we have to use sine. So sine of theta is equal to what? Opposite side will be H over R. So finally, H will be R sine theta. This is the height of this right angle triangle. Now what about the base? So same steps, we can still use that if you want to find the value for the base. Okay, so the base right here, we have again SOHCAHTOA to help us find the value for the base. So we know this one, it is your H and H, and we want to find the A side, which is A and A. So here we have to use cos. Cos of the angle is A side, which is OX, we don't know, over H, which is R. So OX is going to be R cos theta. Okay, so now we have the value for the height and the base. We can use our formula right here to find the area of the triangle. That will be half times base is OX, R cos theta, times height, which is R sine theta. Okay, so let me simplify this. So number one, area of the sector was found to be half r square theta. We have to minus number two, which is area of the right angle triangle, which is r. So half r square cos theta sine theta. So now obviously we have to kind of play with this and factorize. As we can see, we have half and r squared in common. We can factorize this outside. Now will be this. You have theta minus sine theta and cos theta. And this will be shown as required. Now let's move on to part 2 of the question. In the case where the value of r is 12 and theta is 1 over 6 pi, find the perimeter of the shaded region AXB, leaving your answer in terms of root 3 and pi, so exact values. So let's find this. So first thing first, we have to define what are we looking for. So the perimeter will be what? Distance around the region. It is equal to XB, right? XB plus AB plus AX, right? Will be the distance around the object. So we have to find these three lengths to find the value for your perimeter. Now, what do we know? We know now the radius is equal to this, and this is equal to this. So, height, this one, we know from this it is r is 12. Sine theta, theta is 1 over 6 pi. Great. And this one, we know that, so we know this one is what? This one was found to be r cos theta, so r cos theta, which means this have to be 12 minus 12 cos theta, because this whole thing here is 12 radius. We know this is this, so this will be the remaining part, right? So remaining part. How about AB? AB is length of arc, and obviously we can just use the formula to find the length of arc, which is r theta. R is 12, theta is 1 over 6 pi. So we have 3 p's that we need to find the perimeter. So one by one. XB was found to be 12 minus 12 cos of, now 1 over 6 pi is same as 30 degrees, plus AB. AB was found to be 12 1 over 6 pi, plus AX, it is 12 sine 1 over 6 pi. Okay, simplify one by one. So 12 is 12 minus 12. Now what is cos 30? We have to know the exact values of that. Cos 30 is equal to root 3 over 2. So that will be root 3 over 2. Plus, this will cancel out. You will have 2 pi plus 12 sine of, so sine 30, you can check on your calculator, should be half. That should be 12 times half. So simplify, this will cancel out with this. So you'll have 12 minus 6 root 3 plus 2 pi and plus 6. So simplify, this plus this will be 18 plus 2 pi minus 6 root 3. And this will be your answer, or the exact value for your perimeter in terms of root 3 and pi. Let's move on to the next question. The equation of a curve is given to you by this. Okay, now part 1, we have to find dy by dx and d2y by dx2. So pretty easy. We have to differentiate one by one. So dy by dx will be what? First step, because we have a power here, first multiply by the power, right? And then we have to minus 1 to the power. So 3 minus 1 is 2. Then we have to multiply by d by dx of the value inside. That will be just 2. That will be the first part. And here we have to differentiate. That will be 6. So you will have 6 2x minus 3 square minus 6. That is dy by dx. Now moving on, d2y by dx2. That should be what? First multiply by the power again. You will have 12 That will be 2x minus 3. Then minus 1 to the power become 1. 2 minus 1 is 1. Then multiply by d by dx of the value inside, that should be 2. Then this will become 0. That should be 24, 2x minus 3 power 1. That is part 1 of the question. Now for part 2, we have to find the x value of the two stationary points. Now we have to know something is that at the stationary points, we always have to know dy by dx have to be 0. That's the something we kind of have to know on the back of our mind. Whenever we hear stationary points, we have to think about dy by dx is equal to 0. So let's find those. We have 6, 2x minus 3 square minus 6. This is dy by dx. Equate that to 0. Let me send this over here. You will have 6, 2x minus 3 square is 6. We can divide by 6 on both sides, right? To cancel out those two, you will have 2x minus 3 square equal to 1, right? And then we can, if you want to, we can. There's two ways of solving this. We can obviously that will be plus minus root of 1, which is plus minus 1. So 2x minus 3 is plus 1, or 2x minus 3 is minus 1. 2x will be the value of 4, x will be the value of 2. 2x will be the value of minus 1 plus 3, that should be 2. X will be the value of 1. So here we have the two possible values, or two x values of my stationary points. Okay, that is part 1 of the question. Now we have to find the nature of each point. To find the nature, so whenever you hear nature, we have to use d2y by dx2. So at this point is x equal to the value of 1. So let's find this one. What is the d2y dx2 when x is equal to 1? That will be 24. 2 times 1 minus 3. That is minus 1, right? So that will be minus 24. So since it is negative, we conclude that the point at x equal to 1 is a, if it is negative, it should be a maximum point. Now obviously if you had one maximum point already, so we can also conclude that at x equal to 2, it should be obviously the point is a minimum point. Obviously we have one max, obviously the other one should be a minimum as well. So that will be your question regarding differentiation. Let's move on to the next question. A curve is such that dy by dx is equal to 4 minus x. Okay. Now the point P lies on the curve. This is a passing point or a point on the curve. Good to know. So we have to use this somewhere, right? That's why it is given to you. Now, the normal to the curve at P, at the point P, meets the curve again at Q. Okay, so that's something interesting here. Now part 1, we have to find the equation of the curve. Okay, so equation of the curve is simply, we have to find y. Now we understand that if you're given dy by dx, to find y, we have to know y is equal to integration of dy by dx. That's how you would find y. So let's find this. So y will be integration of dy by dx. It is 4 minus x with respect to x. That will be 4x minus x squared over 2 plus c for the constant of integration. Now let's write this down. Y is equal to 4x minus half x squared plus c. Now we have a passing point P, which is 2, 9. That will be x and y. Replace this back in the equation to find the value of c. So 9 will be here. 4 times 2 will be 8 minus half. 2 squared will be times 4 plus c. Simplify. So 9 is equal to 8 minus 2 is 6 plus c. So c will be 9 minus 6 will be 3. So finally, y, which is the equation of the curve, is equal to 4x minus half x squared plus 3. That is part 1 of the question. Now for part 2, we have to find the equation of the normal to the curve. So this kind of question actually comes up pretty often. For example, here, let's say my curve is in this shape. Let's say the point P is somewhere over here. Okay, that's the point P. Now, the normal to the curve at the point P is a line at 90 degrees to this point. Something we have to know is that the normal is always at right angle to the tangent at the point. Right? Something we have to know. This is the normal and this is the tangent of at the point P. Now we have to find the equation of the normal, and as you can see, the normal is a straight line. To find the equation of a straight line, we need to find the gradient of a straight line. So always remember, straight line, to find that we have to find gradient first and then find the equation. So how can you find gradient of the normal? So pretty easy. We must first find the gradient of the tangent, because as you can see, they are connected to each other by this relationship. Now we understand that gradient of tangent is simply dy by dx. So always remember this. The gradient of tangent is simply dy by dx. Now it is at the point where? At the point P, when the value of x is equal to 2. So at 2. Now we know dy by dx already, given to you by this. 4 minus x, that'd be 4 minus 2, that should be 2. Now if the gradient of tangent is 2, we conclude the gradient of normal have to be minus half. And the passing point here, as we know, should be 2, 9. This is my x value, my y value. I can use that to find the equation of the tangent. So let's see. That should be y minus 9 over x minus 2 equal to the gradient. Again, this is just a way for me to find the equation of a line. If you guys have your own method, you can use your own method as well. It's up to you. Cross multiply, you will have 2y minus 18, that should be minus x plus 2. So 2y have to be minus x plus 20. That will be my equation of the normal. Again, if you want to make y become subject, that is okay as well. It is up to you. Now let's move on to part 3 of the question. Part 3, we have to find the coordinates of Q. Now, the normal to the curve at P, the same normal, it meets the curve again at Q. So we have to find the point of intersection of the curve and the normal. Now, the curve was found, the equation was found of the, it was 4x minus half x squared plus 3. This is the equation of the curve. Now this is the equation of the normal. So here we have y as subject already. We can replace in here. So we will have to solve a simultaneous equation. So on one side you will have minus half x plus 10 is equal to 4x minus half x squared plus 3. Now here we have fractions. Obviously we don't like to work with fractions. We have to multiply by 2 everywhere. This will be minus x plus 20 equal to 8x minus x squared plus 6. So now we have no fractions, everything is integer. Now let's send everything to one side so we can solve this. So you have x squared, then we have minus x minus 8 should be minus 9x, 20 minus 6 should be plus 14 equal to 0. Now this one is simply a quadratic equation. We can solve by using your formula, or you can simply factorize. That will be x times x. Now 14 is also 2 times 7. If you want the value of minus 9, we have to have minus 2 minus 7. So x will be 2, x will be 7. Now obviously this one we have already. This is your point P, which was 2, 9. So we're trying to find Q, which is this one. Q is 7. We have to find the y value. To find the y value, we'll just replace back in the main equation. So y will be minus half x is 7 plus 10. Minus 3.5 plus 10, that should be 6.5. But always you can double check so you can avoid making silly mistakes. Minus 3.5 plus 10 should be 6.5. There you go. This will be your point Q, and that will be your question. Part 3. Let's move on to the next question. The diagram shows a cube OAB, CD, EFG. So OAB, CD, EFG. Great. In which the length of each side is 4. This is 4, 4, and 4. Okay, good to know. Now, the unit vectors AI, J, and K are parallel to OA, OC, and OD respectively, as we can see here. Right. The midpoint of OA and DG are P and Q. So OA is right here. This is midpoint. And DG is right here, and Q is the midpoint. Good. So these are simply the given information by the questions. Now, and R is the center of the square face ABFG. Okay, so this is the center of the square face ABFG. So part 1, express each of the vectors PR and PQ in terms of I, J, and K. So first, where is PR? PR is this, going to R. So in this case, we do have to use the diagram to see or to kind of assess how can we find the value of PR. So step by step, if I begin from P, I can first move to PA, right? So first we can move PA. Then from A I can move to the point right here, the midpoint of AB. So from A I can move to, let's call this X. Why not? I can move from AX to AX, and then to go to R I just have to move upwards XR. Okay, so let's find that one by one. So PA will be from this point to this. Now we know that the whole thing here is the value of 4 as given by the question. This is 4, 4, and 4, right? So PA half, because P is the midpoint, from P going to A that will be 2. Makes sense, right? This direction will be I, that will be 2I. Plus AX, same thing. The whole thing here is 4 as well. X will be the middle value, so that will be 2J. And finally, we have to move up to the center, that should be 2K. Okay, that will be part 1 for PR. Now we have to find PQ, so P going to Q. So again, step by step. First thing I can do is I can first move P going to O, and then O going to D, right? And then D going to Q. So I can move from P to Q. Okay, so let's see now. So P going to O will be the value of 2I, will be minus 2I, because this direction is I, but this direction will be minus I, right? Now O going to D, this is going up, we have B, the value of 4K. And D going to Q will be in this direction, that should be just 2J. So finally that should be minus 2I plus 2J plus 4K. Now for part 2, use scalar product to find the angle QPR. So let's find this. So from P we have this and this. So to find the angle we need the vector PQ and PR, which we have from part 1. So we have to use scalar product. That will be PQ dot product of PR cos of the angle QPR. So PQ was found to be what? PQ was found to be minus 2, 2 and 4, right? And PR was found to be 2, 2, 2. Okay, that is first part. Here we have to find the magnitude of each of them. So that will be 4 plus 4 plus 16. That will be root of 24. That will be 4 plus 4 plus 4. That should be 12. Cos of Q PR. Minus 2 times 2 plus 4 plus 8. That should be just 8, right? Scalar product, so minus 2 times 2. So Minus 2 times 2 is minus 4. Then we plus 2 times 2 is 4, plus 4 times 2 is 8. And this will be what? So 24 times 12 will be root of 288. Cos of the angle QPR. Simplify, make cos become subject. So cos of QPR will be, cancel out, you will have 8 divided by root of 288. 8 divided by root of 288 should be this, and cos inverse will be 61.9, correct to 1 decimal place. So angle P or QPR will be 61.9 degrees. That is part 2 of your question. Now for part 3, we have to find the perimeter of the triangle PQR, giving you answer correct to 1 decimal place. So pretty easy. For example, we have, let me write this down, we have this point here, Q, P, and R. Right, so we know a few things already. For example, we know the length of PQ. PQ was found to be root of 24. PR was found to be root of 12. And the angle QPR was found to be 61.9. Right, now we just need to find the length of QR. Now as you can see, we have a triangle. We know the two sides. We know the angle in between. We want to find the third side. We can use the cosine rule. So cosine of the angle QPR was have to be equal to square of those two. That should be 24 plus 12 minus QR square divided by 2 times root of 24 times 12. Okay, so this is simple. As we can see here, QPR is 8 over root of 288, and that should be 24 plus 12, that will be 36, minus QR square over the value of 2, and that should be 288. So simplify, this and this will cancel out. Then we send this on top, you will have 16 equal to 36 minus QR square. So QR square is equal to 36 minus 16. So QR square is equal to 20. Let's double check. 20 indeed. Now finally QR is equal to root of 20. Okay, obviously that is one way of finding the answer. There's many ways of doing this question. Obviously you could try your own way as well. Now we have to find the perimeter. We have to write everything, or we have to add everything. This one, this, root of 24 plus root of 12 plus root of 20. That should be 12.835, correct to 1 decimal place will be 12.8 units. Okay, and that will be your question to finding the perimeter of the triangle PQR. Now the next question is, the function f is defined by f of x is equal to this one, right? That is the function f of x. Now x can take any real values. Okay, x can take any values. Now part 1, we have to express f of x in this form. So we have to complete the squares. Now again, there's many methods of doing that. I have my own preference. I hope you guys can follow through. So first thing first, f of x is equal to 2x squared minus 8x plus 11. Now, first I will need to make sure that this becomes 1. It is 2 right now. I have to factorize 2 outside. That will become x squared minus 4x. And I will just factorize those two. I will leave this outside. No big deal. Now this is 1. Now I can move on to the next step. I have 2. Here we have x squared minus 4x. I have to add something. Add 4 here, the value 4, divided by 2 square, plus 11. Now when you add something, you also have to minus the same value because you don't want to change your equation. So minus the same value, 4 over 2 square. Now because it was inside of the bracket, we also have to give it the value of 2. Right, now we can simplify. This is 2. Here we have x. Here we have minus. Here we have 2. And here we have square. Plus 11 minus, that will be 2 times 2 square, right? This is 2 square. That should be 2x minus 2 square plus 11 minus 1. So 2 times 4 is 8. 11 minus 8 should be 3 plus 3. So by comparison, you can see this is equal to this, where the value of a is 2, b minus 3, and c will be minus 2, sorry. And c will be the value of 3. That will be part 1 of the question. Now part 2, we have to state the range of f. The range is the y value of f, or the upwards value or lower downward value of f. So we have to look at the graph usually. Now there's a reason why they ask you this question after this one, so we can actually use this one to find the value. So looking at the shape of the graph, this is my y-axis and my x-axis. Now looking at this, I know I can use this to find the minimum point of the curve. The value at the end will be the minimum y value. So at the value of y3, and when this is equal to 0, which is at the value of x equal to 2, my minimum point is actually 2 and 3. So 2, 3, let's say it is right here. So this point right here will be my minimum point. Now how do I know it is a minimum curve or a maximum curve? Pretty easy. I just have to observe the coefficient of x squared. If it is positive, it will be a minimum curve. If it was negative, it will be a maximum curve. So just by using those cues, we can actually find the answer pretty easily. So in this case, the graph, the shape will be something like this, right? This will be the shape of my graph. Now, what is the range? What is the y values of this graph? By observation, you can see the value will be always from this point, always equal to this or going up. So y has to be more or equal to the value of 3. That is my range of f. Range, you can write y more equal to the value of 3. Now for part 3, I have to explain why f does not have an inverse. So pretty easy. A function does not have an inverse when it is not a one-to-one function. In this case, if you can see, if I were to draw a line here, right, it cuts the curve at 2 points. Because of that, it will not have a inverse. So because f is not a one-to-one function. That's the reason why. Now the function g is defined by this 2x squared minus, so same thing, okay, same thing, where x has to be less than a, where a is a constant. Great to know. Now part 4, state the largest value of a for which g has an inverse. So pretty easy. So now we do realize that a function has an inverse if it is a one-to-one function. Now we can see that was the shape of the curve. However, like this, it will not have an inverse because if you draw a line, it will meet at 2 points. To have an inverse, it will need to meet at only 1 point. So let's say if my curve is like this, if I draw a line, it will meet at only 1 point. Now the maximum value of a, as you can see, I have to define my value of a, which is my x value. It can only be maximum value of this was 2, right? Because that was 2, 3, that was the minimum point. So that is the maximum value that a can take. But if I take more than this, the curve will continue, and if it continues, it will no longer be a one-to-one function, as you can see. So there you go, the max value that a can take will be the value of 2. And the last one, when a has this value, obtain an expression in terms of x for g inverse. So pretty easy. To find g inverse, we have to use this. So we know g of x is the same thing as 2x minus 2 squared plus 3, right? So now to find inverse, we have to first let y equal to the value of g of x, which is 2x minus 2 squared plus 3. Simplify. We can send y to the left hand side first. That will be this. X minus 2 square. X minus 2 square should be y minus 3 over the value of 2. X minus 2 should be plus minus root of y minus 3 over 2. And finally, x have to be 2 plus minus y over 3 over 2. So G inverse, it is in terms of x, that will be what? 2 plus minus x minus 3 over 2. Now we have to choose which one will it be. Is it plus or minus? So as you can see, x have always to be less than 2. So you have to be 2 minus x 3 over 2. That will be G inverse of x. Now we have to also find the range of G inverse. So we have to know something here. The range of G inverse is equal to the domain of G. So what is the domain of G? Let's find out. Domain of G was, domain is x value was this. So range of G is pretty easy. Range of G will be just y, because we express range in terms of y, have to be the same thing. So this is your answer for the range of G. And that will be the question in relation to function.